Okay, I think we're ready to get started then. We're going to talk about fractions and solving equations. So I got some equations together that we can talk about. We usually start with more basic equations. I don't know if Stephanie was raising her hand because she was having trouble or if that was just her playing around with things. So I just want to double check before moving forward. Might have just been messing around. I'll keep an eye on the chat just in case, but I'll keep moving forward until I know for sure. So, solving equations, we start with a more basic and then they build up and do perfect. Great, Stephanie. Now we're all on the same page. Feel free, if you have questions, to send me a chat message at any time so that I can answer as we go. So two-step equations, we have a variable. It can be on the left or it can be on the right. Writing this as 7 equals x divided by 4 minus 21, they could put it in this order and you would still solve it the same way. If you like the variable on the left, because most of the time it starts on the left, you are always welcome to just rewrite it. As long as you switch the entire sides, that doesn't matter. An equal sign, you can just switch everything completely and get that variable on the left. So with our equation, what we want to do is to do opposite operations. The equal sign splits it into two sides. We have our left side and our right side. And our goal is to move everything away from the x. So the way this is set up, we want to move everything from the left to the right. If it had started out this second way, we would want to move everything from the right to the left. We're just always trying to get away from the x. And most of the time, our first opposite has to do with this minus, or sometimes they have a plus. So if we're doing minus 21, we want to do the opposite of subtraction. So what's the opposite of subtracting something? Very good, Annie. Plus, we want to add the 21. So you can do this two ways. Some people like to write it on both sides because what you do to one side of an equation, you must do to the other. Some people feel like that's confusing to have so much written down. So instead of writing it on both sides, on the side that we're trying to get rid of, so that minus 21, we just cancel it instead of writing it, and we write it on the other side. It's really up to you. As long as you do the opposite operation on the opposite side, then we're good to go. So we add these together. And by doing the opposite, we got rid of the minus 21. So we just need to bring down everything else we didn't get rid of. So we do have a fraction here, but really our fraction is just division. We are dividing by 4. I should write in our equal sign. That shouldn't disappear or else it looks kind of funny. So we want to keep that written in. Hi, Kim. Thanks for joining us. Just want to take a quick moment. Kim, can you hear me, first of all? You can write a chat message to me if you can hear me. And then also, to kind of catch you up, we are solving a two-step equation by doing opposites. So the first opposite we did was to add 21, which gave us the 28. And now we have to figure out our next opposite operation. So opposite of dividing by 4. Right now, this is currently x divided by 4. So what's the opposite of division? Multiply. Good. So we are going to times by 4. So this is one of the reasons why I prefer to just cancel it out and say times by 4 over here. It looks kind of funny if we write times by 4 on both sides. Sometimes we do 4 times 4. It's easier just to say, I did the opposite, cancel out the divide by 4, and do 28 multiplied by 4, which we can use a calculator for. I'm going to use Google Calc. You could do that by hand if you want. Quicker to just plug it in. 112. And so that's your final answer. Once you get it down to just one variable with one number on the other side, that's our final answer. So any questions on our two-step equations so far? So let's move on then to multi-step equations. Multi-step equations. Okay, so you were confused or your confusion has been fixed. I just want to clarify, like, is it easier to write just the plus 21 instead of adding it to both sides? I just want to clarify to make sure before moving on. And in the program itself, they do write it kind of confusing. Okay, good, yeah. A lot of students prefer to write it on one side only. The program, instead of presenting it written below 2, often they'll write it to the side, which makes it even more confusing. Instead of saying plus 21 underneath, they'll put plus 21 here, and then 7 plus 21 over there. Sometimes it's easier to watch a YouTube video instead, or come to like this session. And I can show you kind of the easier ways, how to kind of interpret it and be like, oh, really all they wanted you to do was add 21 and be done. Yeah. Okay. So a multi-step equation is going to make this a little more complicated overall by having a lot more going on. Instead of just 2 steps, we're going to have to do some other things. So multi-step equations, I kind of have a little process. This is what I always look for. First, we look if there's distribution. You may or may not have to do this. Distribution would come up if there was a number in front of a set of parentheses with a variable and a number inside. So you check for distribution. This problem does have some parentheses involved. There's parentheses around this negative 3.4c, but there's no number in front. There's no addition or subtraction inside. These parentheses are not about distribution. Sometimes when they have a negative number, they just put parentheses around it to show this is negative. You're adding negative 3.4. So you look for distribution. Sometimes you skip it. If there's no distribution to do, you go to step 2. We want to combine like terms on each side of the equation. So again, we know where the equation is split by that equal sign. Our equal sign splits it into 2 different sides, left side, right side. So we want to check both to see, is there any like terms to combine? On our left side, there's only one number. It's not possible to have like terms. You need more than one thing for a like term. On the right side, there are some like terms. So like terms are either numbers that don't have a variable or 2 things that have the same variable. So what 2 things could I add together on this right side of the equation? What are the like terms on the right? The two C numbers. Thank you, Annie. So we can add these together. Negative 3.4 plus 1.7. Again, that's something I don't want to do in my head. I clear out my calculator. The Google calculator only has the subtraction symbol. If you have maybe a handheld calculator or you've downloaded an app or something, some calculators have a subtraction symbol and a separate negative symbol. Google Calc, we just use the subtraction symbol for everything. So negative 3.4 plus 1.7 is negative 1.7. So anything that didn't combine, we still keep. So we still have negative, or 3.4, we still have equals negative 13.6. And now we know negative 3.4 plus 1.7 is negative 1.7c. We can't type the c into the calculator. So on the calculator, it only showed negative 1.7, but the c does come along. So now we start doing our opposites. So now this is actually a two-step equation. It's what we did on the first page. When we do opposites, we're always trying to move away from the variable. So the c, we're trying to get stuff away from the c. This time we're going from the right side to the left. If you don't like that, you could rewrite it. You could switch everything from the right and write it first, and then put equals 3.4. But let's practice this side. So we almost always do the opposite of the subtraction or addition first, and that's the number without the c. So the negative 13.6, no variable, that means we want to do the opposite of subtracting 13.6. So we've talked about our opposites. Subtraction, the opposite was addition. It's almost always the opposite we do first. We're going to add 13.6. When we've done the opposite, it gets rid of that negative 13.6. That is the point of doing the opposite, to get rid of it. And we combine together. Calculator again, 3.4 plus 13.6 is 17. So this opposite is a little bit more difficult. When you're left with one number next to the letter, it doesn't say plus c, doesn't say minus c, it's directly touching the c. What opposite do you think we should use here? We have negative 1.7 touching the c. What opposite do we use to get rid of the negative 1.7? Okay, and that's a common thing to say. Plus, because you see that negative sign, that is what our brain wants to do. Our brain is like negative, plus, done. This one's a little bit trickier because they don't show how the negative 1.7 is actually interacting with the c. They assume you know. The negative 1.7 is actually multiplying by the c. They assume you know when there's a number touching a letter, it is multiply. So we actually want to do this opposite of multiply, but it's hard to remember because the thing we see automatically negative, brain wants to say positive. But instead, we have to do the opposite of multiply. So what's the opposite of multiplication? Division. Good. So that's something to always remember. Number touching the letter, we divide. And since we're only doing the opposite of division, we don't change the negative sign because we're not doing the opposite of the minus sign, we're doing the opposite of the multiply. So we keep it dividing by negative 1.7. And 17 divided by negative 1.7 is negative 10. Again, you know you're finished once you have one variable left and one number left. You want variable equals number. So any other questions on this particular problem? Okay. If anyone else has a question, let me know. Right now, I'm going to assume no other questions and move forward, but we can always go back if you do think of something. So we talked about multi-step equations. We're always going to look for that distribution and then combine like terms. It gets a little trickier again if they end up with variables on both sides of the equation. So there's a couple types of problems they can ask with this. One will be to just solve, which we're going to do next. That's more similar to what we've been doing. This one specifically just asks which equation is an identity. So it's a little bit different. This is not asking you to solve. It's not asking you to find, m equals 12. An identity means both sides are the same. So on a question like this, it has to be multiple choice. They couldn't have you just solve this and get an answer. We have to check each option they give us and see if each side is actually the same. So all we're going to check for is, can I simplify anything on the left? And can I simplify anything on the right? So the left side, we have no like terms. We have one variable, 7 with an m. That's our variable term. And this negative 5, our number term or constant term, doesn't have a variable. So they cannot combine together. On the right side, we do have like terms. We have our 8m minus m. Again, there's something they assume you know here, and that's sorry, I've got to start that sentence again. That is that if they don't put a number in front of the variable, you assume that it is a 1. People who came up with math and discovered all these things were like, oh, I don't have to write this 1 every time. I know it's a 1. But then they assumed everyone else also knew that, so it's something we have to remember. If there's not a number written there, it's a 1. So we combine those together. And 8 minus 1 is 7m. You combine the numbers in front and leave the variable. So the identity part is both of these sides should be completely equal. So are these sides exactly the same? No, they're not. This is not our identity. Not the same. Answer choice A was not our answer. So the problem with a question like this is sometimes it's time consuming because you have to go through every individual answer choice. So now I'm going to try answer choice B. I need a little more room than that. So I'm going to rewrite this. So again, we have to simplify each side. We're going to just take each side individually see if there's anything we can combine together. On the left, we do have some like terms again. 3w minus 1w. There's that invisible 1 again that we have to write in. And then we subtract 3w minus 1w is 2w. And the 8 didn't have anything to combine with, so we just bring it down. On the right side, we do have a setup now to do some distribution. We talked about distribution and how we might need to do it in some of our problems, but this is the first one we're seeing so far. So when we distribute, you're only working with the number directly touching the parenthesis and its sign. We keep the negative sign with the 2. So the 4w for now is just going to come down. It's not part of this distribution process. So to distribute, that means the negative 2 gets multiplied by both things inside. Negative 2 multiplied by w, but then you use it a second time. The negative 2 repeats itself, and it gets multiplied by the negative 4. So when you multiply negative 2 times w, there's not really much to do there. We just write it negative 2w. That's actually doing the multiplication for that. And then negative 2 times negative 4 becomes positive 8. So now we write plus 8. We do the multiplication first, and that determines whether we put a plus or a minus sign. So now we have some like terms. This time we have to do 2 steps on the right. We distributed. Now we combine our like terms. So if we combine 4w minus 2w, what comes out? What do we get when we combine those together? 2. 2w, because 4 minus 2 is 2. Very good. So now we look at each side. That's as simple as it can be. And they do match exactly. This is what we call an identity. Once everything is simplified, if they match exactly, we have an identity. So this should only come up like once or twice on the quiz. It's not going to be the main bulk of the quiz. You cannot keep going. That is a great question. Technically, yes, you could. You could keep going. But because of what they asked you to do, you don't need to keep going. If they asked you to solving, you would keep going. If they just ask you to show which one is an identity, then we can stop there. Yep. So great question. That's all about what they ask you to do and not whether you could or not. It's a very good question on that one. So next, equations with variables on both sides. This is more of the main portion of this section. And I'm labeling these. This isn't just the topic. This is the name of the section in the course. I'm trying to keep it labeled by what you're going to see in the course. So this is going to be the main part of the quiz where they actually ask you to solve. It'll say something like, solve this equation. So to solve, we're going to still need to check for any distribution or combine like terms. These steps may or may not need to happen. Distribute. But you should always check for them as you go through combine like terms. So on the particular problem we see, we could distribute. We have the parentheses around a variable and a number, and there's a number in front. We can multiply that number in front in. So that 3 will get used 2 times. We do 3 times the 2x and 3 times the negative 1. And I am going to draw, you don't have to draw a line, but it can kind of help you organize your thoughts and say, okay, this is the stuff on the left, this is the stuff on the right. So we multiply this in, 3 times 2x. This time we can do a little more. We can do 3 times 2, which is 6. Last time it was just the number next to the letter. That was all we could do. But if there is a coefficient in front of the variable, just multiply it out. And then 3 times negative 1 is negative 3. So that means we write minus 3. So we did our distribution. We look for any like terms, but they have to be on the same side. So on the left side only, there are no like terms. And on the right side only, there are no like terms. You're looking for each individual side when you're looking for those like terms. So normally we would go to opposites, and we are going to kind of do opposites, but we have to actually get the entire variable 4x over to the 6x. We want to take the right side variable and move it to the left. So on the problems we've seen before, I'm going to go back to this page. When we were solving this and we had a number next to a letter, I said, well, this was multiply. We need to do the opposite of divide. But that only moved the negative 1.7. The C was still there. We left it. What's different now is we want the 4 and the x to move to the other side. So this time we want to do the opposite, and we have to do the opposite of addition or subtraction. So our goal is to move the variable term on the right over to the left. So this 4x is currently positive 4x. It's again another invisible thing. You assume if they don't write a negative sign, this is going to be a positive number. So the opposite of adding 4x is going to be minus 4x. And when we minus it instead of divide it, we move the 4 and the x. The 4 and the x both cancel. So that makes it a little bit different, and we'll actually need to do the division step again at the end. But when you want to move the number and the letter, you have to do addition or subtraction. So our opposite is going to be add or subtract. It depends on what you start with. If this had been a minus 4x, our opposite would then be plus 4x. And then you combine those. 6x minus 4x is 2x. And now we're down to a two-step equation again. Most of these more complicated equations, we always get it down to a less complicated one that we can solve. So what opposite should we do next? We're trying, good, add. We're trying to move this negative 3 now to the other side. So we're going to add 3. When you move it over, cancel out the one you did the opposite of. So opposite of add or subtract with your constant instead of your variable. So 2x equals 18. And then our final opposite when we have the number next to the letter, but we only want to move the 2. We don't want the x to move. Now we're going to divide. The opposite here, because this is really 2 times x, our opposite is to divide. And we saw in the very first problem, so our opposite here was to divide. On the very first problem, when you had a fraction, our final opposite was to multiply. You kind of have to be flexible with equations. I can't give you exact instructions that work for every situation. So that's why I have to give, multiplication or division. It depends on what the problem asks for. So any questions on solving equations with variables on both sides? Again, feel free. Let me know if you have questions at any time. Perfect. I'm glad this is being helpful, Stephanie. That's the goal. Give you guys a little bit of help so that going through the lessons will hopefully be easier. So we requested some fractions. So I figured we could do an equation problem that maybe involved a little bit of fraction work. So we go through that same process. The steps are check for distribution, check for combining like terms. If there's variable on both sides, move the variable on the right to the left. Do opposite of addition or subtraction. Do opposite of multiplication or division. So kind of a long process, but if you kind of think through, this is what I have to do every time, hopefully it'll become easier and you'll be able to get through these a little bit better. So, step 1, look for any distribution. On the left side, there is nothing to distribute. On the right side, we have 2 things we could distribute. We're going to do this 1/2 times the 4 and the 1/2 times the 5. Here's where our fraction comes into play. So you'll notice, though, that in the instructions, it said round to the nearest 10th if necessary. That means they don't want your answer as a fraction. Hi, Paulette. Thanks for joining us. Hopefully you can hear me. We are currently working on solving an equation, specifically an equation with variables on both sides. We have moved to the more complicated equations where we're going to have lots of steps. Our first step has been to check for distribution, which this question does have. So currently we are distributing the 1/2 times the 4 and 1/2 times the 5. The 1/2 is going to be used twice. So when we do this multiplication, and I'm going to actually move this 2x minus 3 down since we had that step to do of distribution. 1/2 times 4. It seems like it's going to be pretty complicated because everyone hates fractions. It's pretty much across the board, and everyone hates fractions. But since this said to round to the nearest 10th in our answer, we're going to get rid of the fractions by just plugging it into a calculator. 1 divided by 2 times 4. When we plug it into the calculator, we're just going to use the divide sign. Your calculator doesn't need a fraction button. We just type in 1 divided by 2 times 4. Makes it so we don't have to worry about the fractions. We just get the final answer. So, 2x. 1/2 times 4 came out with the 2. Then we do the 1/2 times 5. Same idea, 1 divided by 2. So anytime you see that fraction bar, we're just going to hit divide in our calculator. Multiplied by 5 is 2.5. We get a decimal, but that is okay. Our answer said to round to the nearest 10th. So we're fine if this comes out as a decimal. After we practice all our equation stuff, I'll do maybe some just fractions where it comes out as a fraction. But a lot of the time, you can make it into a decimal and not have to worry about fractions anymore. So now we have to go to the next set of parentheses. This time we have to distribute twice. Equations can be so flexible. You have to think about all the different steps. So you might not have to only distribute once. Sometimes we have to distribute twice. So Paulette cannot hear anything. I'm going to take a minute and write her a message. Oh, like the sound is cutting out? I'm not sure. Yes. I don't know if I have a way to fix that. Maybe my internet connection just is... Okay, so Kim's sound is fine. It's possible if your internet connection is having trouble, it might make the sound be cutting in and out. It's better now? Okay, so working for Annie, working for Stephanie, working for Kim. I'm gonna just double check on Paulette. While Paulette is hopefully checking on her sound, I'm going to keep going on the problem. We only have about 13 more minutes, so I want to get as far along as possible. So we're distributing the -2 in, and you have to multiply it by both things again. -2 times 3 is -6, and -2 times -x. Again, we use that -2 twice. That becomes +2x. So we checked on our distribution, and we had to do distribution twice this time. Sometimes you don't have to do it all. Sometimes you have to do it twice. Depends on how the problem starts. Now we look for any like terms to combine. On the left, no like terms. On the right, we have a couple of like terms. We have 2x and 2x, and the +2.5 and -6. So we combine these all together. 2x plus the 2x is the 4x, and 2.5 minus 6. Again, you may not know how to do that in your head. That's fine. Calculators are great. Okay, so 2.5 minus 6 is -3.5. So I'm going to write one more message to Paulette. When you guys joined, do you have to hit like a join conference button, or did the sound start automatically for you? Since I'm hosting it, I don't know what it looks like when you join it. Okay. So hopefully that's the issue. Any luck now, Paulette? Can you hear me? Okay. So again, okay, perfect. Now Paulette can hear us. So Paulette, I'm going to just catch you up really quick since you haven't been able to hear anything I said. We're working with equations with variables on both sides. It's from the equations with variables on both sides section. When we go to solve an equation, we check for any distribution, which this had 2. We had to multiply 1/2 times the 4x, and then also 1/2 times the 5. We do it twice. That's what it means to distribute. And then we had to do the negative 2 times 3 and negative 2 times the negative x. And when you do all that multiplication, we got down to here. So next you check for any like terms on the same side. We have the left side, which didn't have any like terms, and the right side, where we added 2x plus 2x to get 4x, and 2.5 minus 6, which I plugged into a calculator. Sometimes decimals are hard to do in your head, so just plug it in. That gave us negative 3.5. So we do have a variable on the left and a variable on the right. We want to move the variable on the right to the left. So currently this is a positive 4x. What is the opposite of adding 4 so that we can move it over to the left? Opposite of addition. So opposite of addition is going to be subtraction. Good, thank you, Stephanie. Opposite of addition is to subtract. And 2 minus 4 is negative 2. If you don't like positive and negatives, plug it in. Calculators are super helpful. Use them. I love calculators. They are great. So everything else, we moved the variable. Everything else, we just bring down. Now our next opposite, almost always, there's very, very few incidents. I don't know why I'm having trouble speaking sometimes today. There's very few times where you do multiplication or division first. It's almost always opposite of addition or subtraction. And we're always trying to move stuff away from the variable. So we want to do the opposite of that, minusing 3. So opposite of minusing 3, adding 3. Once you've done the opposite, we put the opposite on the other side. I always remember opposite operation, opposite side. And you cancel out the one you did the opposite of. So negative 3.5 plus 3. Oh, sometimes your calculator may leave stuff behind, so just clear it out if that happens. Negative 3.5 plus 3 is negative 0.5. And then we have one last opposite. Our last opposite is almost always the opposite of multiplication or division. So just to stress again, I know it looks like we should do addition. That happens to almost everyone. I see it all the time, which is why I brought this kind of problem up. Even though that's a negative 2, the 2 is touching the x, so we're actually doing the opposite of multiply. They don't write it in, but this is negative 2 times x. So our opposite of multiplication is division. We want to divide by negative 2. I don't know what negative 0.5 divided by negative 2 is. So again, we go to the calculator. This time, we have the negative 0.5 already in from our last problem, so we can just hit divide by negative 2, and that gives us 0.25. Now we're to a positive number. But our instructions did say to round to the nearest tenth. The tenths place is immediately after the decimal. So we have to ask ourselves when we round, if we have to do a rounding problem, do we leave this as a 2, or is it going to round up to a 3? So should our answer be 0.2, or should our answer be 0.3? What do you guys think? Does it stay 0.2, or do we round up to 0.3? Very good. 0.3. Next to the 2 is the 5. If you have 5 through 9 after, I'm going to have to write it to the side. That means you round up. 2 will round up to 3. If it had been a 0 through 4, you leave it. And if that was 0.21, we just leave it 0.2. So our final answer on this one, I'm going to have to write it kind of in the middle here since I ran out of room, is 0.3. We only have a few more minutes. I had prepared a word problem, or we did have a request for fractions, so we could skip the word problem and maybe talk about a fraction problem instead. Do you guys have a preference? Okay. We talked a little bit about fractions. Okay, Stephanie says fraction. So we will go with fraction problem. So when you're working with just fractions, let's say we want to add 2 fractions together. The easiest method, and this works for addition or subtraction, I would use the same method if this said 1/2 minus 3 over 5. So the easiest method of adding fractions is you make them have a common denominator by multiplying by the denominator of the other fraction. I know that sounds hard, but basically we say, okay, 1/2, I'm going to multiply that by 5. That's the bottom of the fraction that is not 1/2. And 3/5, I'm going to multiply that top and bottom by 2. That's the bottom of the fraction that's not 3/5. So kind of like an equation you said what you did to one side you have to do to the other. A fraction, what you do to the top you have to do to the bottom. So that's why we multiply top and bottom. So we multiply straight across. 5 times 1 is 5, and 5 times 2 is 10. Same thing over here. 3 times 2 is 6. 5 times 2 is 10. Then when we do the addition, the denominator stays the same. You keep it that 10 the entire time now that it matches. And we only add the numerators together. 5 plus 6 is 11. So you could leave your answer like this, 11 over 10. You might need to write this as a mixed number. So a mixed number, you say, how many times does 10 divide into 11? Well, it can only go in one time, and that's your big number of your fraction. And then we look for the remainder. 1 times 10 is 10, and 11 minus 10 is 1. So the remainder of 1, that's the top of the fraction piece. And then just like we kept 10 along this entire thing, mixed numbers should have the same denominator of your fraction. So 11/10, they could leave the answer like that. Maybe it's just this. Or you could rewrite it as 1 and 1/10. Unfortunately, we are out of time. We did 2 group sessions before where I talked about fractions as well. If any of you are interested, I can send you the links to those group sessions. We recorded it. I did record today as well so that anyone who missed this can have access to it. So does anyone want the links to the previous group sessions, or I can save these notes. I'll send you the notes of what we talked about today. So Annie wants me to send the link, Kim and Stephanie. Okay, so I'm gonna write your names down, and as soon as this video uploads, and as soon as I can get all those links together, I will send that out to you guys. So we're gonna try and do this every week. We would have it next week at the same time as we did this week, and I'll send out reminders, and probably there'll be announcements on your dashboards again. Thanks, Stephanie, for joining us, and Kim and Annie, and Paulette was here for a little bit, and hopefully I'll see you guys next week too. So have a great day, everyone.